Now, this game allows us to, as mentioned, do things that we can't do in real life. As you see here, I'm kind of creating a gateway on one wall. It's basic, but it is really interesting. And my experience with this game is that not only do we enhance our genuine and general understanding of the subject, but also it awakens a greater interest of the subject. We become more interested in physics. We find physics more fun. And that is why I think gaming is a great idea for education. And now, Fredrika will talk a bit of her experience with games in school.
Over time, as you're building cities and developing technologies, establishing an army and conquering others' territories. And there are different ways to win the game, both diplomatic and by use of military force. And now, before I go on telling you about this game, I guess many of you are probably wondering how we could possibly learn anything from playing this game for an entire month. And to be honest, so was I. I came from school where pen and paper were the only learning tools we used. And the thought of starting here at Nordahl Grieg with all this technology, that was a really frightening thought. However, after a few days, maybe a week, the thought of this technology became more and more interesting. And the same goes for this gaming project. Now, first of all, it's not like we were sitting in the classroom and gaming for 4 weeks. In both English and Norwegian class, we were blogging about our experiences and thoughts regarding this game. And at the end of the project, we made a film in social studies, where the theme was international relations and power, where we used screen videos like this to show examples. And now in social studies, the theme was international relations and power, and the civilization game illustrated these terms perfectly. Now, it gave us a real image of how you can develop power, use this power, and see both positive and negative consequences of every single move you make. Now, I was really surprised about how positive I thought this experience was, and I really learned a lot. I mean, of course you can learn by reading in a book and writing down keywords, as you always have done. However, this way of learning made it so much more interesting to learn. You weren't just reading about these conflicts, you were actively taking part in them, and I think that's the whole difference to get us involved in our teaching. Now, I absolutely believe that computer games has a future in schools of tomorrow, and I'm glad I got to try it out this time.
Afraid of being digitalized?
I was terrified we had to do mathematics on the computer.
But Alan, don't you use mathematics on your computer?
Yes, that's very correct, Gina. We do use our computers a lot in mathematics, and we have done so ever since the first year I started at Nordahl Grieg in 2010. Just get the poor button. Right, I have to admit it was a challenge at first. After 10 years with just pen and paper, a so-called traditional and classical way of learning mathematics, it was a huge change for completely fresh upper secondary students. But on the other hand, Nordahl Grieg encouraged us already the first year to try out new technology and a brand new way of learning. And today, I am very glad they did. 2.5 years with unconventional and exciting ways of learning mathematics have developed and kept on improving not only my digital skills, but also my general understanding of mathematics, which also is quite important. Having that said, I could go on and on talking about mathematics, but that would still just be words. On that note, I would rather show you a quick example of how we make use of digital resources in mathematics. So, right, I have this task here of a function, f of x, and the task asks me to find the root of f of x. That means find the place where the function crosses the x-axis. So, to do so, I want to write in a program called mathtype. So, I simply equal the function to 0, replace it with the expression, is 4x equals 0, Then I can put the x outside the parentheses. Plus 4 equals 0. X equals 0, or x squared minus 4x plus 4. That's a square sentence. Everybody knows that, right? And x equals 2. Right, so I now have that the roots of f of x are x equals 2 or x equals 0. Now I've done it the hard way. I've done it by doing it by hand. But I can also use a digital resource called GeoGebra to solve this task. I go into here, GeoGebra, I simply write the function x minus 4x plus 4x, then I get the function here. Now I get to visualize what was on the paper. And now I can find the roots by putting in a command, nullpunkt in Norwegian, f of x, and then I get point A and B. You can see here on the left-hand side that point A is 0 and point B is 2. Exactly the same thing I found earlier. Now I can copy this one and simply paste it into my document. Look at this beauty. This is really the way we do mathematics at our school, which you can also see from one task from the last math test we had at school, looking like this. We still have the traditional way of learning mathematics, but we also challenged ourselves into using new digital resources to stimulate learning. And in many cases, we find that the combination of the two works best and leads to the best way of learning. So, by being bold minds, I would say that students at Norway have a huge advantage learning mathematics. But why shouldn't also others have this advantage? Right. We've come to an end in 79. He failed about 200 times before he got it right. But you know what he said? I didn't fail 200 times. I only found 200 ways not to make a light bulb. And it's sort of the same thing we do and act at Norway. Gaming in class, working and learning together on social cultural platforms, and using digital resources to stimulate learning are all examples of our belief that if you do not try, you will never learn nor make progress. Please follow us on Facebook or Twitter or both, and thank you so much for listening.